problem that we did yesterday. So you have let me get out my book and get you everything because I just have my answers on my handheld. So it says the figure shows a rectangle inscribed in an isosceles right triangle whose hypotenuse is 2 units long. So when I looked at this, that told me the hypotenuse was 2 units long. So that represented this length down here. Oh, sorry. So this side and this side are equal to each other because it's isosceles. And this length from here to here is 2, which meant that this coordinate and this coordinate where my lines hit the x-axis were the ordered pair 1, 0 and negative 1, 0. So that's what I got just from like the beginning information. For part A, it asked you to express the y coordinate of P in terms of x. So in order to be able to express this point here as a y coordinate in terms of x, you needed to be able to find the equation of the line for this graph right here. So since this is an isosceles right triangle, what you could do is use Pythagorean Theorem to find the length of this red piece. And what that would do would be able to allow you to find your slope. And that would give you the y-intercept or the point right here. You could actually also think of this as smaller right triangles. So technically, right here, you have another smaller right triangle, and this piece is 1. So, Caitlin, just in general, what was your thought process to which way you wanted to look at this? Okay. So I feel like it's getting crowded. I'm going to realign this. So what does that blue graph, if I took away that rectangle, what does that blue graph almost remind you of? Okay. Yes. Or I was getting out more like the shape of the graph is an absolute value. So what that means is this represents one line of the absolute value, and the other side represents the other, and we know that their slopes are going to be opposing. So yes, it also should remind you of a triangle, which is where we're going to get our slope from, or our length from, if we're struggling to see that. So this is my 90 degrees. That 90 degrees also is helpful because it tells you that these two lines intersect, and their intersection point is also 90 degrees, which also tells us the two lines intersect and are perpendicular to each other, meaning their slopes are also opposite reciprocals, as I just discussed with the absolute value being a piecewise. So we need to find the height of this point here, which they labeled as B, in order to be able to find that slope. So let's find the height of our triangle. So to find that height, we need to find this piece here. So we can do a Pythagorean theorem twice. So we'll call the outside lengths, let's not do x because they used x in the problem. Let's call those outside lengths A. So you have a squared plus a squared equals 2 squared. So I have 2a squared equals 4. Divide both sides by 2. And I get a equals root 2. And then we know this length here is 1. So height is equal to, again, Pythagorean theorem. We're going to get the height by saying that h squared plus 1 squared equals the square root of 2 squared. So you get h equals the square root of 1, meaning the height of this triangle is 1. So that makes this point here 0, 1. So now for part A, your slope is y2 minus y1 over x2 minus x1, or 1 over negative 1. And my y-intercept is 1. So my linear equation is y equals negative x plus 1. So then point P, in terms of that, is simply negative x plus 1. So the point on your graph, sorry, I just need room. Becomes P is x comma negative x plus 1. And then for part B, you would use that information because it says express the area of the rectangle in terms of x. So area would be the height, which is negative x plus 1, times the width. Well, if that's coming out x units to that point, so here's my rectangle again. This represents x units out. That would represent x units in the opposite direction as well. So the width would have to be 2x. And then I'll leave you from there to find your derivatives and get your critical points. But hopefully that helps you with the setup of that problem.